here's my exam, my exam 2 review. Now again, what some students tend to think is, oh, if I can just do these exact problems then I'm good for the test, because the test is going to be just like it. And the answer is no. There might be some problems that are similar to these for sure, but the content is what I'm looking for, is do you understand what's going on behind that's allowing you to answer these questions? Because that then opens up you to solving all sorts of related problems. So that's what we want to make sure we go for. So this one right here is section 6.1. It's a little bit out of order, so I apologize for that. Stanley Cup is the hockey championship. Data represents the number of games played, X. From 39 to 2011. There's no dispute. No champion in 05. It was canceled labor dispute. Okay. So X is the number of games played in a best of 7. Okay, it says it right up here. Best of 7 series. Okay. So A, construct a probability model for the random variable X, the number of games. So I'm going to say X, the number of games. Always identify your variables, even if it seems redundant. So they could play 4 games, which would be a sweep, 5, 6, or 7. And now we got to get the probability. Well, we got to add up how many do we have here. So let's see, 20 plus 17 plus 19 plus 16 is 72. So this would be 20 divided by 72 is, I'm going to be rounding these, 28%. 17 divided by 22. 17 divided by 72, sorry. 24%. 19 divided by 72 is 26%. And 16 divided by 72 is 22%. And if we add those all up, sometimes this might not be 100 because I've rounded, and it could be like 99 or 101. And if that's the case, that's okay. But it looks like we got 100% right here. So this would be 0.28, 0.24, 0.26, 0.22. So that's my probability model. A probability histogram just looks like this. We can call this X because I defined it up here, and this is the percent. So we go 4, 5, 6, 7, and then we'll go, how about this? Let's go 30%, 20%, and 10%. So 4 would be 28%, 5 would be 24%. Always a good idea to write those up there. 26% for 6, because remember the 7 goes into the next one. 22%. Okay, so there's B, computing the mean of the random variable. So that's E of X, or sometimes we call it mu. 4 times 28 plus 5 times 24 plus 6 times 26 plus 7 times 22. Okay, 4 times 28 plus 5 times 24 plus 6 times 0.26 plus 7 times 0.22. You don't need any parentheses because order of operations, it'll do the multiplication first. So this would be 5.42 games. So that's the average number of games in a best of 7 series. And then of course the standard deviation of X is the square root of the difference between my data, the average difference between my data and the mean. And the way we calculate that is we do 4 minus 5.42 squared times the probability, the weight of it. 5 minus 5.42 squared times the weight of that. Plus 6 minus 5.42 squared times the weight of that. Plus 7 minus 5.42 squared times the weight of that. And I'm actually just all in one shot on my calculator. Square root of 4 minus 5.42 squared times 0.28 plus plus parentheses 5 minus 5.42 parentheses squared times 0.24 plus parentheses 6 minus 5.42 parentheses squared times 0.26 plus parentheses 7 minus 5.42 parentheses squared times 0.22. What I said is exactly what I put in there. Close parentheses under the radical. We get 1.12. Okay. Yeah, there we go. 1.11. I rounded it. Okay. Games. Alright, now we're back to, this is chapter 5. Oh, this is, I said 6.1. This is the chapter 6 review. It was from section 6.1 though. Okay, so let's look at number 6. Let me get some more space on here. I think I can do that. Okay. Alright. Okay, number 6. E of E is 76, F is 45, E and F is 32. What's E or F? You can go ahead and use the formula. Say, oh, probability of E or F is probability of E plus probability of F minus the probability of E and F. And they told me the value, so I get just to plug it in. 76 plus 45, but there's some overlap, so I have to subtract it. 76 plus 0.45 minus 0.32 is 89. Now another way to look at this would be this. Here's E. Here's F. So there's 32 in the middle. Since E is 76, all of that is 76. So 76 minus 32 will give me 44 over here. So that was 76 total. F is 45, so that would make this, what, 13? So now E or F would be that, or that, or that, because or always means both. And 44 plus 32 plus 13 is, of course, E as well. So that's a different way to do it. All right. I'm not sure what problems I assigned you. Let me check. Okay, number 8. Double check there. Suppose E and F are independent, and we know the probability of E is 0.45, probability of F is 0.2, probability of E and F. Well, if they are independent, that means one does not affect the other. Normally this is this, probability of E times probability of F given that E occurred. But since they're independent, it doesn't matter that E occurred, it's just the probability of F. So it's point. Okay, sorry. It's going to be 0.45 times 0.2, which should be 0.45 times 0.2, 0.09%. And 11. Suppose E and F is 0.35, probability of F is 0.7, probability of E given F. Well, we know this expression is, we're given F, so that's my denominator. Now what's probability of E? What's probability of E and F happening, because we know F happened. This is also a formula that you have to calculate. It comes from this formula over here. So this would just be E and F is 0.35 divided by 0.7, which is 0.5. Okay. And number 12, actually do A and C. So A is just 7 factorial, which is of 7 times 6 times 5 times 4 times 3 times 2, which you can do your calculator here. 7, and then go to math, go to PRB, and down to exclamation point, factorial. It's a large number, 50, 40. And then B is, or C, 9, 4. Which is 9, math. This is how many ways can you choose 4 things out of 9 when order does not matter. In other words, a different order is a different, oops, 26. This is choose 4 from 9 and order does not matter. In other words, a different order is a different thing. Okay, and let's see, let's do 13 and then we'll call this video good. Game roulette, there's 38 slots, 0, 0, 0, 0, 1, 2 at 36. Metal ball spun, falls into one of those. It says these are green, odd or red, even or black. So A. And always write out what you're doing. Probability that it falls into a green. That'd be 2 out of 38. So it's got a 5.3% chance of landing in the green. B. Probability it falls into a green or red. Well, there's 38 slots. How many of them are green? How many of them are red? Well, let's see. There's 38, so 36 of them are red and black, so half of them. So I'll have 18 red, 18 black, and 2 green. So green or red is going to be 2, 18, so 20 out of 38, or 52.6%. C. Probability that falls into 0, 0, or red. Well, there's 38 total. Red slots, there's 18, 0, 0 is 1, so that'd be 19 out of 38. Should be 50%. And D, determine the probability that it falls into 31 and black at the same time. Well, 31, odd numbers are red, right? So probability of 31 and black. Well, 31's red, so you can't do both of one, so that's going to be 0 out of 38, or just 0. Okay, and the term we use, yeah, it's impossible. Okay, so we'll stop at that one and pick it up on the next one.